Hey, everybody. Welcome to another episode of the Subnet Show. I am Gabriel Cardona, and I am joined, as always, by my amazing co-host, Connor Daly. What is up, Connor?
I need a catchphrase. Maybe I'll try a different one out every week. I was thinking just like, may the avalanche take you all, or follow the avalanche, ski down the avalanche or something like that. Well, welcome.
From Snowflake to Avalanche.
Yeah.
Awesome. Thank you, as always, for your time. Stoked to have you here. And today we have some very, very special guests. We have the team behind Sherpa Cash. Sherpa Cash is a new privacy protocol, which is launching on the Avalanche network. And the community has a lot of excitement built up around this. And so we've been wanting to get this team on here since we started, and we're very grateful for their time. So thanks, Tyler. How's it going?
Good. How are you guys doing? Thanks for having me.
Yeah, man. Thank you for coming. Appreciate the time. And then also, Rabib, nice to meet you. How's it going?
Hi, doing well, and thanks for having me on.
Yes, absolutely. Okay, so there's a lot to talk about because privacy is a huge topic, and Sherpa Cash just has a ton of buzz around it. They had a really huge ceremony, I think one of the biggest that's happened in the space, which we'll cover. Before we do that, part of the vision for this whole podcast is that we want to get to know the people behind the different projects, and we kind of want to get a sense of what their crypto journey is like and what their crypto vision has been like. There's so much to talk about that I don't know we have a ton of time to be able to deep dive on that, or else we'll probably spend the entire evening talking about that. But there is a couple of things we wanted to talk about. So first, I think we'll just kind of go at the super high level, sort of like what brought you into crypto, and how did you first discover it, and what is the precursors of your crypto journey? Let's start with you, Tyler.
Oh, yeah. So I started getting involved in crypto really in 2012 is when I started getting seriously involved, and around 2015, 2016 is when I made the leap to working in crypto full time. I've always been interested in software development, and then crypto ended up being sort of the perfect melting pot of a bunch of different things that interested me, like cryptography and distributed systems and stuff. So it was sort of a natural fit. Got really into protocol development around 2016, especially participating in the Bitcoin Cash community and doing protocol development stuff there. Shortly after that is when the Avalanche consensus white paper came out. And first time I read it, I thought like, okay, I don't know, who cares? Because I didn't get it at the time. I thought this sounds a lot like classical consensus. I then later realized that like one of the things that's so cool about it is that Avalanche is actually just like a generalization of all quorum-based consensuses. So when I was reading it and I was thinking, well, this is just quorum-based consensuses, it was actually because it was like so foundational. It was explaining like how quorum-based consensus worked at a foundational level, and the sort of the nuance and the really cool parts kind of went over my head at the time. But then Bitcoin Cash was interested in implementing Avalanche as a way to augment its Nakamoto consensus layer, as a way to provide faster transactions and potentially make attacks on the chain more expensive. So I started really diving into Avalanche and figuring out how it worked and how an implementation of that would look, trying to get that to work on Bitcoin Cash. One thing that stood out to me immediately that I thought was really cool was, in Bitcoin and Ethereum, in order for them to work, they're sort of like very tightly integrated into the underlying state that they're coming to consensus on. Whereas I found that Avalanche, it sort of worked for, as long as you had a robust and a functioning Sybil resistance mechanism, you could sort of come to consensus on any sort of decisions that you want. They didn't necessarily have to be like economic in nature. So I thought that was really cool. And then once I knew that Avalabs was building an Avalanche-based platform. But once I started to learn more about it and was learning that it was really leaning into a lot of the strengths of Avalanche, like strong finality and this ability to come to consensus over a diverse set of things, which is essentially what subnets is. I thought, this is extremely cool, and I wanted to get involved in working on it. And so I came into it because the protocol was interesting. But then once I started developing on top of it, building indexers and building dapps on top of it, it very quickly showed itself to be not just a really cool protocol, but a really great platform for building stuff on top of. So I've sort of continued my interest in the protocol up to the application layer, and trying to utilize Avalanche when I'm building my Web3 related things. So I guess that's a quick overview of how I got here.
Got it. And so I also was very involved in the Bitcoin Cash ecosystem. That's where I originally met and found out about Tyler. I believe you were in Australia, if I remember correctly. Yes or no?
Nope.
Were you? Oh, okay. For some reason, I thought you gave a presentation there. Anyway, yes, I first found out about really Tyler's work in the Bitcoin Cash ecosystem, and I considered him then, as well as I consider him now, really to be like an exceptionally good engineer. And at the time, I thought of him as being in the very handful of best engineers in the Bitcoin Cash ecosystem, and he was working very closely with the lead Bitcoin Cash implementation, which is Bitcoin ABC. And then also working very closely with BCHD, I believe, is the Go implementation by Chris Pacia, also a very, very smart guy. And so whenever I found out that Tyler was actually joining Avalanche, that to me was like a big red flag that the brain drain was happening, and that the best engineers from all of the different ecosystems were going to end up into the Avalanche ecosystem. So it's one of the things that made me take the actual, not Avalanche, I was aware of Avalanche, the consensus, but it made me take Ava Labs, the company, a bit more seriously whenever I saw that Tyler was going to be joining the team. So how much were you involved in the actual Avalanche pre-consensus implementation that was done on Bitcoin Cash? And did you work on the ABC side of it or the BCHD side of it?
Yeah, so by the time I got into it, Omri, the lead developer for Bitcoin ABC, had made pretty significant progress in sort of figuring out how to combine the two protocols, the Nakamoto consensus and the Avalanche consensus.
So real quick question. So is this trying to run Bitcoin with Avalanche consensus or Bitcoin Cash with Avalanche consensus, or are you trying to like build a Bitcoin Cash subnet or something like that?
No, so in short, it's basically a layer on top of Bitcoin Cash. So it was working directly with Bitcoin Cash itself, and then building a layer on top of it where the Bitcoin Cash layer would continue to use proof of work Nakamoto consensus, just like Bitcoin's algorithm. But then this higher level layer, which would consist of ideally the majority of miners at the lower level, would use Avalanche to quickly decide on transactions and blocks before they get encoded into the Nakamoto consensus. So the idea is that, with the Nakamoto consensus, any changes take 10 minutes to happen, basically. And so the time scale on which decisions get made on the network is very long. And so with Avalanche, the idea is that miners would quickly resolve these decisions. As long as they're online, they have all of the information they need to do that safely. They would quickly decide what gets into blocks. And then when blocks get mined, they would quickly decide, this is the block we want to stick with. And then later, if a conflicting block comes along, as long as the majority of hash rate is supporting it, then it can instantly reject that block and not waste any time. If a minority of hash rate is participating, then they could basically significantly increase the cost that it would take to attack them by almost sort of playing a game of chicken, where they say, we know that you're trying to reorg us, and we're just going to refuse to go along with it until you reach some extremely excessive amount of work over past what we've already committed to. So, if you really want to force us out of this position, we're not going to give up just because you gave us one block more than we saw before, or 2 blocks. You're going to have to sink some $10 billion into trying to override our decision if you really want us to give up on it. So that's sort of the idea there.
The so-called pre and post consensus, right?
Correct. Yeah. So pre-consensus is transactions are flying around the network and you are deciding pretty much instantly using Avalanche that you're not going to confirm any conflicting transaction with that. then that gets put into a Nakamoto consensus block. And then when that block comes out, post consensus is deciding on that particular block. So Omri did a whole bunch of the work. I mean, I'm sure other people helped, but I think he did the majority of the work, at least in the Bitcoin ABC implementation. And then I am much more comfortable in writing Go than I am in C++, which Bitcoin ABC is in. So I ported over first I worked through the white paper and I implemented the Avalanche algorithm itself. And then started going through Bitcoin ABC and seeing how the actual pre and post consensus was constructed from that. And then implemented a test network from that. And then from that point, we started working together to try to figure out exactly what sort of parameters we wanted to use, like how exactly we wanted the civil resistance to look like. We knew we wanted it to require people to hold some number of coins, so some UTXOs, and we wanted it to incorporate time, for example. So you needed to hold some aged UTXOs, and we started working on that system. Ultimately, that was about the point that we were at when OpenBazaar shut down, my day job at the time. So I switched to Avalanche and unfortunately did not complete the work on the Bitcoin Cash stuff. I do know that the eCash chain, which is what Bitcoin ABC has become, is continuing that work. So I've been monitoring it, but I have not actually been involved since early 2020.
Yeah, so just for clarity there, last November, there was another Bitcoin Cash network upgrade, so-called fork. It happens every 6 months. And out of that came a project called eCash, and it's driven by Omri Sachet and the original team that was the Bitcoin ABC team, which was the sort of main Bitcoin Cash full node implementation for several years. And so now there is a network out called eCash, which is, a derivative of Bitcoin into Bitcoin Cash into eCash. And it does exactly what Tyler was just describing. It has implemented the Avalanche pre and post consensus. I'm not sure exactly what the state of affairs is, but that's what they're going for. And they're also going to have like sub chains and a couple other different innovations. And so I guess before we go to Rabib, I wanted to kind of wrap it up. A couple of thoughts there. Number one, I just wanted to get your sense, Tyler. What was that like actually implementing Avalanche consensus? How approachable was it? And so that'd be number one. And then number two, just to say, the reason I find that whole experience so interesting to me is that it really sort of speaks to the technical innovation that Avalanche consensus is. And so, of course, at Ava Labs and in the Avalanche network, we have, the Avalanche platform, which consists of Snowman consensus and Avalanche consensus and DAGs and linear blockchains and subnets and virtual machines. There's a whole platform. But then completely decoupled from that is Avalanche consensus, which is something that you can overlay as pre-consensus or post-consensus on existing networks. And again, I think it just kind of speaks to the actual technical innovation that is Avalanche consensus and showing that people are already implementing it on other chains. As far as I know, I think Flare is an implementation of the Ripple protocol with Avalanche consensus. Somebody please correct me if I'm way off the mark there. But again, it just kind of speaks to that. So before we wrap it up and ask Rabib about his crypto journey, what was that like for you trying to implement Avalanche consensus? Was it approachable? Did it feel like a crazy rabbit hole? What was your experience?
Yeah, sort of both at the same time. It's interesting. It's sort of deceptively simple in a lot of ways. Some parts sound easy, and then you get into doing them, and then it's a lot more difficult than you would think. And a lot of stuff seems like it's going to be more difficult to start off with than it ends up being. And then, a lot of stuff seems simple and you think it's simple and you did it. And then later, Chris Passia is like, this doesn't even do what you think it does. So what are you doing? Yeah, but, all in all, I think it's more complicated than Nakamoto consensus in the fact that in Nakamoto consensus, you're effectively just taking states, you're giving them some weight, and then you're choosing which one's the heaviest. Whereas Avalanche, the consensus is sort of emergent based on the network properties. So you have to make sure that you've got healthy nodes, they're well distributed, the Sybil protection is correct, all that kind of stuff. but all in all, I will say it was simpler to get something going than I thought that it would be. But I think that getting something robust and production grade has been significantly harder than I would have thought initially. We're fortunate to have Stephen and Dan and Aaron around to really do all of the hard parts, why I gotta just sit around and come up with cool sounding ideas, and they figure out how to make them not blow up.
Nice. Cool. So Rabib, thanks for joining us. Really happy to have you around. Why don't you give us a sense of what was your crypto journey like? How did you sort of end up in the space and working on this project?
Yeah, so I think my first exposure to cryptocurrency was like around 2012 when I just started naively playing around with, Bitcoin clients. But that was never anything seriously in depth. I think the first time I really started learning about blockchain was in 2017 when I was actually in law school. I worked for this, I was doing this internship at a legal clinic that focused on Canadian internet policy. And so they asked me to write an FAQ on blockchain and its implications on, I guess, law in Canada. So that's how I sort of really started learning about the nitty-gritty behind, how Nakamoto consensus works and how blocks are composed and everything. And but at that time, I had never done any sort of like actual interaction with any of these protocols because I was kind of stingy with my money as as a student might be. So I think later, it was actually in 2020 when I started thinking about how I should invest my money, that I decided to learn more about cryptocurrency. And well, at the time, I already knew about Ethereum. And so I decided to learn more about it. I started reading the Ethereum white paper and then the yellow paper. And I thought, hey, like, why don't I actually develop something on this? Like, or why don't I develop smart contracts? So I started thinking about that. And then at some point on Twitter, I ran across this guy named Emin Ginsire, and I just started reading about Avalanche through his tweets, and then eventually I got around to reading more of the docs, and yeah, it really caught my attention, and I thought, hey, I'm really interested in Avalanche. Why not develop on Avalanche? So that's what sort of brought me to this point. I think actually prior to Sherpa Cash, I actually connected with Tyler about making basically forking Tornado and like developing the zero knowledge ecosystem, let's say, on Avalanche. And so I actually deployed a version of the Tornado protocol on Fuji before I ever started working with Sherpa Cash. And so we started working on that. But when we found out that Sherpa Cash was happening, we said, I think, mutually agreed that, let's just, see where that goes and maybe help them out. And then eventually they asked me to come on the team. And that's how I ended up where I am now.
So why were you interested in Tornado? Why Sherpa? Why not go build a DEX or a DeFi protocol? So what led you into the privacy realm?
Well, actually, I did my master's in cryptography, specifically in quantum.
Might have lost you for a second. So you did your quantum cryptography master's in law school. We might have lost Rabib still. So Tyler, why did you join Sherpa? Yeah, why Sherpa? Why Tornado?
Yeah, so I mean, I've always been a big advocate of privacy, sort of going back to the early Bitcoin days. It's funny. I mean, I think it's kind of funny because Bitcoin's actually not private at all, but it initially attracted a bunch of privacy conscious people. And then we sort of realized, oh, this is actually the complete opposite of privacy. That a lot of people still kind of think that it is, but in general, you know, one of the biggest deficiencies with cryptocurrency is the requirement to broadcast your transaction to everyone. For one, it doesn't make any sense. It's, you know, when you pay with something in cash, nobody knows about it except the people you're paying. If you pay with a credit card, the only people that know are the people you're paying and the payment processor. So to go from that to a system where everybody knows everything, both isn't great for privacy, but then also it's also not good for scalability, because everybody having to know about everybody else's transaction is not great. So that's how I sort of got into the zero knowledge and privacy realms. Tornado, well, I should say ZCash is sort of the gold standard of privacy through zero knowledge proofs. And Tornado Cash on Ethereum is a really good implementation of the general Zcash mechanism in a way that is compliant with EVM smart contracts. So there's a number of different potential ways to get privacy that people have tried, but this general mechanism of using a zero knowledge proof to break the link between the sender and the receiver is what I think is best. And so that's what Tornado does. And when I wanted to try to implement a privacy solution on Avalanche, that was sort of my go-to. And so I think there was a Twitter thread, I don't remember who started it, asking what do you want to do, or what would you like to see on Avalanche? And both Rabib and I said, you know, a Tornado Cash fork. And so he reached out to me and we talked about that. And then, like you said, we found the Sherpa project and that they were working on it. So we contacted them and ended up teaming up, and it's worked out really well. You know, I think all of us are both privacy advocates and zero knowledge proof advocates both. And so we've sort of got a little collective going of the people on Avalanche that are interested in this technology. And so it's really been a great project to be a part of because of that.
So zero knowledge proof is a big word. I know maybe not all of our listeners are familiar with it. Would you mind explaining what that is?
Sure. So yeah, it is a little bit complicated. And I think to make it make more sense, has to get a little bit more complicated. So in full, it's a zero knowledge computational integrity proof. The important part here is actually the computational integrity, which means you can run some program, you can execute some code, and then you can prove to somebody else later that you did it correctly. And so that is sort of the magic. The zero knowledge part just means when I prove to you that I executed this computation correctly, I can be selective about which inputs I gave to you. So, you know, I could say I have two numbers, X and Y, and when I multiply them together, the result is 36. But I'm not going to tell you what X and Y are, but I can prove that I did that computation correctly. Or I can tell you, you know, I'll reveal to you what X is and what the output is, but I won't tell you what Y is. In that case, you could reverse engineer it. But if you have something more complicated using, say, elliptic curves, then there's a lot of tricks that you can do by being selective about the information that you let people see. So the idea is because it's zero knowledge, a lot of the information that links the sender to the receiver that is necessary to make sure that a transaction is correct, you can sort of prove that computation to validate that transaction happened correctly without supplying the information necessary to actually validate it yourself. And so I can prove to you there was a sender that had the funds and he successfully sent them to a receiver, but I don't have to give you any information about who they were, or I can tell you that in zero knowledge.
Yeah, that's really cool.
Yeah.
Another example of zero knowledge proofs I see tossed around a lot is Sudoku puzzles. You know, I can prove to you that I've solved the Sudoku puzzle, but I don't have to tell you what my solution is.
Yeah.
And so it's the same way of, if you want to transfer money, you can say that, you know, this person transferred from A to B, or someone transferred money to somebody else, but we don't have to say who it was, exactly how much. And I think the problem with Bitcoin's privacy is exactly like you said, of this distributed ledger. The blockchain is all about broadcasting who spent what money, the money transferred from person A to person B. And so people think, well, you can't identify me. I'm not, my name isn't person A. Person A is 0xABCD1234. But it turns out, we have to KYC whenever we buy crypto in many countries. And so somebody actually does know the link between, your actual real name and the address on the blockchain. And then you can see that, okay, if you have money here and you sent money to this person, and I know who that person is, I know you sent money to him, or this looks like you're sending money to yourself, or you received payments from this person. And it actually de-anonymizes really quickly. And there are some companies actually out there who are profiting off of de-anonymizing Bitcoin and working with the government to try to say that, like, oh, this person was a known drug dealer and you sent him money. Did you buy drugs? Maybe. Or money laundering or whatever. And so that's like what a company like Chain Analysis is kind of working on, like de-anonymizing, finding out how money flows in these systems and trying to de-anonymize so that paying customers can figure out who did what.
Yeah, and especially as as more stuff with DeFi, as more people move the types of finances and financial instruments that they participate in to the chain, all of that information just gets linked together on your one address. Or even if you try to split it into other addresses, it's usually, you can tell that you're just trying to split up your assets. And so it's really pretty trivial for anybody, once they know any one of your addresses, to go in and see pretty much everything about you, because everything's linked together. So the privacy situation in crypto generally is really a pretty big mess.
And this is something that affects us, like, personally. This is not just like a theoretical problem, because personally, I would rather not disclose all of my net worth, all of my crypto holdings, all of the DeFi apps I'm a part in. But I'm also, quote unquote, a public figure. I work for a company that requires me, some of my work is very public, and you can tell if you look some addresses I hold. And if you know those addresses, if you know some of the projects I'm associated with, if I don't take any precautions to separate out my wallets and make sure they never touch, you could easily discover all of the crypto I hold, on Avalanche or on Ethereum or whatever. And so this is something that I think about a lot, and potentially something that I will be using Sherpa to do, which is to, if I'm trying to move money between different public and private accounts, make sure that those are not actually linkable or traceable back to me. So Rabib, could you tell us how Sherpa or Tornado works?
Yeah, sure. So from an end user perspective, it's just you go to the Sherpa Cash website and you select one of 3 pools at the moment, which are all denominated in AVAX, so 10, 100, and 500 AVAX. So you pick one pool and you deposit that amount of AVAX into the pool via smart contract call. So you just hit this deposit button. And then what you get back is this note, which later, like, this note is just the string, which later when you go to the withdrawal step, you input the note and you input the recipient address, and then that amount of AVAX will arrive in the recipient's wallet, once all gas costs are paid, whether by you or the relayer that you're using.
So where does this note come from?
This note basically is generated for you by whichever website's running whichever computer's running the website. So then this note essentially acts as not the proof, but the preimage of the proof. So you run that through the proving algorithm, and then you get basically an integer out, and then you send that to the blockchain.
So is this a front end app, and like the proof is there, this pre-image of the proof is generated like in my browser, or is there like a back end somewhere that is computing it and sending it to me?
I believe it's in the browser. Correct me if I'm wrong, Tyler.
Yeah, no, it's all done in your browser. I like to think of the note as sort of a single-use private key. You don't use it multiple times because doing so would link your different deposits together. But your browser will generate this random number, and then it hashes that random number. And then when you deposit coins into the contract, they get deposited along with the hash of your note. So nobody can figure out your note because they can't reverse the hash. All they can see is the hash.
And then you use the note to withdraw your tokens later.
Exactly. So when you withdraw your tokens, you provide a different hash along with a proof that the two hashes have the same note pre-image.
Right. So if I use the hash directly, you could see that the input and the output address have the same hash. So the key magic here is that we're using the zero knowledge proof to say that these two hashes are associated with each other, but not reveal what the input hash was.
Yeah, exactly. So if I generate a random number to act as my note, it's basically a huge private key, and we can call it X. And then you have two different hashes, hash 1 and hash 2. And given either hash, there's no way to determine either what X is or which of the other hashes relates to it. And then you just use a zero knowledge proof that can tell people this hash is associated with one of the hashes that's in the deposit set, but we're not going to tell you which one it is. So you know that that the hash is related to one of the deposit hashes, but you have no way of knowing which one it actually is. That information can only ever be known by somebody who has the note and can calculate both hashes.
And
which hopefully,
yeah. And the real punchline of this is basically I can use it to move AVAX from one address to another without having a link between them.
Exactly. So you deposit from address A, and those funds basically all go into a pool together along with the set of deposit hashes. And then when you want to withdraw, you provide your matching withdrawal hash, and that removes some tokens from the pool and adds to the withdrawal hashes. But you can never tell, when I withdraw to address B, there's no way of knowing which deposit it's linked into. So there's no way of knowing which address A those funds came from. Exactly.
So I think
go for it.
As I was gonna say, the rub here is that you have to deposit a fixed amount of AVAX. It has to be the 10, 100, or 500, because I think that the danger with using Sherpa or Tornado is that there's side channels, or there's ways you could maybe mess up. And one of them, this is kind of like a common privacy thing of happens with medical records a lot, is just like, well, we removed the names from all of the participants, but one of the people in the study was 6'9" and 150 pounds. And so how many 6'9", 150-pound people are there? You don't have the name, but you can just kind of figure out due to the other information around that, oh, it's actually this person. And so it's the same thing. If I want to send a very specific amount of money, if I need to send 420.69 AVAX, there's only going to be so many people sending that much money versus, if you're always in like fixed amounts, that like eliminates that side channel, because it's just one 500 AVAX transaction, $100 AVAX transaction.
Can you speak? Yeah, I'm sorry. I keep cutting everybody off. There's a little bit of a lag. I apologize. Go for it, Tyler. Finish your thought.
Oh, yeah. So I was just going to say, when we were talking about, you withdraw and then you can't match up that withdrawal to a deposit. That's only true as long as all of the deposits look exactly the same, like you were saying. So if I tried to deposit 420.69 AVAX and everyone else only deposited, 100 AVAX, and then later I go withdraw that, well, there was only one deposit that deposited that amount. So if we allowed people to, say you want to go and you just want to dump in however much you have in your wallet, then you've got thousands or tens of thousands of different amounts that have all been deposited. And so when you go withdraw that amount, you don't have the anonymity of every person that has ever deposited. You only have anonymity among people that deposited exactly 42069 AVAX or whatever. So it's important that we provide just a small fixed number of pools that people can use. Otherwise, it really fragments the anonymity that you can get.
Got it. So I have a question, Tyler, having worked so well at such a high professional grade in the Bitcoin ecosystem, which of course is driven by a UTXO model, and it's got a scripting language, but of course it's not quite as powerful as what's available in the EVM type world. And then, now in an EVM type world where you have so-called Turing complete smart contracts and zero knowledge proofs and a whole different set of primitives with which to build privacy tools. Can you speak to the pros and the cons on both sides? So things like Sherpa Cash versus things like shufflers and mixers and that whole paradigm of technology?
Yeah, that's a great question. So just briefly, if you don't know exactly what Gabriel's referencing, there's sort of two general approaches to achieving on-chain privacy. There's the zero knowledge proof approach that we've been talking about so far, that Sherpa uses and Tornado uses, that ZCash really pioneered. And then the alternative model is sort of more like what Monero is doing. Also, you may have heard of CoinJoin or CoinShuffle or Cash Shuffle. These all work using what is referred to as combinatorial explosion. So the idea is, unlike a zero knowledge proof where you're perfectly breaking the link between sender and receiver, with combinatorial explosion, you're joining together a bunch of different potential UTXO inputs and saying some of these are being spent and some of them aren't being spent. And through many layers of those transactions, it gets difficult to tell which coins were actually the ones that were spent and which ones weren't. So you sort of have the two approaches are basically an information theoretic break between sender and receiver, and just more of a practical, make it way too impractical to actually compute who the sender and receiver could have potentially been. Those are two sort of different strategies. On an EVM based chain, doing the combinatorial explosion route is prohibitively expensive. The account model itself is really precludes being able to combine a bunch of different potential input states. The CoinJoin model, the combinatorial explosion model, this is probably one of the better bets for UTXO based currencies like Bitcoin, or currencies that, I should say UTXO based currencies that don't have a fundamental privacy system built into the layer. So another example would be Avalanche's X-Chain. Could be viable for this type of system. One of the reasons that they haven't seen much traction before, like for example, CoinJoin, I think was originally proposed in 2012 or 2013, and has never really seen much usage, just because by necessity you have to send a whole bunch of transactions, and because fees get really expensive on Bitcoin and similar chains, it's just way too expensive to practically do that. On Avalanche, if we can maintain low fees, and I honestly, I think for something like CoinJoin to be viable, we'd probably even need to lower the fees a little bit more from where they are now. It's probably not too far off, but with a little bit lower fees, it would probably be more practical to do this type of combinatorial explosion technique. I think it would be interesting to try. I hope somebody does it, and I want to see how well it works. Sort of, if I had to bet on one system over the other, I sort of like the zero knowledge proof way a little bit more. I find it a little bit more pure, as long as there are not flaws in the zero knowledge circuits themselves, which is a big caveat. But as long as that's the case, then you are making a full information theoretic break in the sender and receiver, which I find to be a little more reassuring than just having a bunch of different potential inputs. But I really think that people should try to pursue both, and it would be great if we have both. And then one last point to that I'll say is just the model of the Avalanche platform in having the X chain and the C chain and being able to send tokens across chains is amazing, because it means that tokens or coins, whether it's AVAX or potentially other tokens in the future, can really benefit from each model. You can go to the X chain and do something like CoinJoin, or you can go to the C chain and use Sherpa, or you can do both. I think that it's an amazing opportunity that Avalanche has to really sort of experiment with both models and see how well they work together, or how well one works versus the other.
That's really cool. I actually had never thought about that, but yeah, you could potentially create, okay, I don't want to spoil this, but yeah, you could potentially create like a subnet or something like that that could do really cheap zero knowledge transfers. So if you wanted to anonymize your tokens, you don't necessarily have to go through Sherpa. It might actually be cheaper to export off the C chain, go to the anonymity chain, and then do your thing, and then come back or something like that. But in that spirit, if you'd like to write into the show, you can reach out to us on Twitter at what is the handle? I'm sorry, I don't know, Gabriel. Is it Subnet Show?
Yeah, Subnet Show, one word. Yes.
Subnet Show, one word. Like Maj Detko did, and Maj Detko asks, if the Sherpa Cash project succeeds, will you have higher ambitions, such as launching a ZK-Subnet that would give Avalanche privacy on par with projects like ZCash or Monero?
You want to take that, Rabib? You want me to?
I mean, I was just going to say my initial thoughts was, I definitely want that functionality on Avalanche. So I was planning on, having a part in building that out, whether that was part of Sherpa or not. So that was my initial thought on that. I don't think we've had very much in-depth discussions on that in the Sherpa team, but it's definitely something that I would like to further explore with them in actually fleshing out that kind of VM.
Yeah, I think that there's a lot of there's a couple interesting things that a privacy specific subnet could afford us. One is just better efficiency if some of this tooling is built in natively to the VM versus being implemented on top in the EVM. We can get more efficient, which means we could drive down costs. Just like roughly ballpark number, I would be surprised if a native implementation of verifying the circuits in, for example, a Rust VM, I'd be surprised if that's not at least 10 or 100 times faster than trying to implement it in the EVM like we do now, and that can translate to cheaper fees, which is great. The other big thing that is potentially interesting with a Sherpa subnet is that currently Sherpa requires this relayer system, which maybe we could talk about a little bit more. And it is sort of not ideal. It's not the biggest issue in the world, but it does add a small amount of complexity to the system that we try to keep away from users. But essentially, just the requirement to pay gas to send a transaction to withdraw funds from Sherpa means that without a relayer, there is no way to withdraw funds to an account that doesn't already have AVAX in it. You have to have AVAX in your account to pay the gas to receive a withdrawal from Sherpa. And if you try to use sort of AVAX that's already linked to you to pay that, then you've blown your privacy. If you have AVAX that's not already linked to you to pay the gas, you didn't need Sherpa anyways because you already have AVAX that's not linked to you, so it doesn't matter. So to get around this, we have this relayer system. Potentially a Sherpa subnet would allow us to configure things in a way that lets the withdrawer pay for transactions instead of the person that's actually issuing the transaction itself. So there are some things that we want to experiment with a subnet that we might be able to do, but we don't have any solid plans or any announcements lined up anytime soon.
So you mentioned these relayers. So who are the relayers? Like, is it possible to become one, or are they a fixed number of parties? What are the details there?
Yeah, good question. So the software to be a relayer is open source. Anybody can download the software and run one. You have to opt into it. It's not like just going to the Sherpa website makes you a relayer or something. depositing doesn't make you a relayer. It's software that you have to run. Anybody can actually run the software. When you go to make a withdrawal on the UI, you're presented with a list of available relayers. And so you could put in anybody's relayer you want, or we provide a list. Exactly how you get your relayer listed there is to be announced. That's going to tie a little bit into how our governance is going to work. But essentially, it's possible for anybody to become a relayer. It may be in the future that you have to do some governance participation in order to get listed in the main UI as a relayer, but there's nothing precluding anyone from doing it themselves and putting in their address manually.
Does Sherpa require that there's a certain number or certain percentage of relayers behaving honestly, or what happens if you misbehave? Is there some safety threshold or anything like that?
Yeah, that's a great question. So while it is unfortunate that we have to have these relayers at all, they are not trusted in that they can't break your privacy and they can't steal your money. The only thing that you trust them to do is when you send them a withdrawal proof, you are relying on them to publish it to the chain. And in exchange for that, you pay them a fee out of your withdrawal. There's a system that allows you to pay the relayer out of your withdrawal with the unconnected money instead of having to have connected money to pay for the gas. So they do get incentivized to include your transaction. In that sense, it's sort of like a miner or a validator. So I guess technically the requirement is, in order to use the system without needing gas money like we intend, there needs to be at least one honest relayer, just somebody who will propagate your proof to the chain. And if the relayer that you try is not honest, they can't break your privacy, they can't steal your funds. The worst they can do is just not broadcast your transaction, and you'll have to try another relayer.
Got it. And so perhaps more of a step back and a bit of a primitive question, but again, Mojdeko asks on Twitter, since your project is a Tornado Cash fork, how many changes have you made to the original code base, and are there any that are significant enough that you want to point them out?
Yeah, I think this is a really important question because obviously anything in the crypto space, code needs to be super secure, right? And the Tornado Cash team has a really good reputation. They have some amazing smart contract developers, and in particular, they are some of the world experts in zero knowledge proofs. So one of the values that we get out of using their software is all of the careful engineering and auditing that they have put into it. So that said, we're very careful to not change things that were too critical. I kind of look at there to be a stack. You can sort of start at the most critical at the bottom, which is the ZK knowledge circuit code that actually implements checking the withdraw hash and the deposit hash match. This is code that if it's not correct, would allow somebody to steal funds, and also is the most specialized in terms of the expertise required to understand how it works and audit it. So you sort of have the zero knowledge proof code, then you have the Solidity smart contract code on top, then you sort of have the relayer system that we just talked about, and you have the UI on top. And so you get sort of most critical to least critical. And then along those lines, we're very careful to go from, least changes to most changes. So the core Snark code, we changed nothing at all. All of the audits that were done to that code are, fully applied. We didn't change anything. The smart contract code on top, the only stuff that we changed in that was removing the ability to update the Snark later. So in Tornado Cash, they have the ability to upgrade their Snark, and this is a legacy from when they were still developing their Snark system. And at this point, they have overrided their ability to update it any further. So we went ahead and just totally stripped that code out. So from the beginning, we will not have the ability to do that, which is great. So this is a small change, but it's only removing code. So it's a fairly safe change. Then on top of that, the other pieces that are a little bit less critical have had significantly more updates in order to make things a little more optimal, a little more performant, use less resources, and at the UI layer to try to make things a little bit more polished and easier for people to use. But the security critical stuff, we were conscious to change very little.
And what is the Snark stuff? You said it's sitting below the Solidity stuff. Is it in Go? Is it in Rust? What exactly is it written in?
So it's actually, it is written in a special purpose language called circom. And it is a language that exists only to describe zero knowledge proof circuits.
What's it called?
It's called circom, CIRCOM.
We'll leave the links for all this in the description, just so you guys want to check it out later. Go ahead.
Yeah, so people may have recently heard about the Hermes network that was just recently purchased by Polygon. It's now called Polygon Hermes or Polygon ZK Sync or something. Anyways, they developed circom as their solution for writing the zero knowledge circuits that they need. So it's sort of a little bit like a JavaScript-y looking language. But when you compile it, you basically get these really long numbers that represent polynomials and do all of the crazy Snark math stuff. Yeah, so that's what the actual code is written in. So like, for Tornado, there's, I think there's like withdrawal.circom, and it's a circom description of what the withdrawal ZK Snark looks like. And then we compile that, and that gets compiled down into EVM bytecode eventually, so that there is an Ethereum smart contract that is capable of actually validating the proof described by this circom file.
Oh, that's really cool. Go for it.
In addition to circom, there are a few other libraries that are being used. So for example, Snark.js and Wasm Snark, which were also both written by the Hermes team, and these I believe are written they're written in JavaScript. So that's basically what we're dealing with.
Yep.
So where does the where does the
Snark
Snark code run? Is that on the relayers, or because it's not in the smart contract?
Yeah, so in the browser side, you generate the proofs. So the proving is all done in the user's browser. And then the verifications are all done on chain inside the EVM. So the smart contracts have a Snark verifier encoded into the EVM bytecode that gets processed.
So does the circom compile down to like Wasm?
It compiles
or it compiles to JavaScript.
It compiles directly to, I want to say it compiles directly to EVM bytecode. I think
wow.
You output Solidity, but
okay.
In the end, the target is going to be EVM bytecode.
Cool. So one other thing, you were kind of talking about some of the technical differences between you and Tornado, but Synexero writes in and asks, what makes Sherpa Cash instead of just being a Tornado Cash fork? So I know you mentioned earlier you were doing some governance and some stuff like that. You also have your own brand. So I guess what do you see as being kind of like the philosophical difference between the two projects, or like where are you going to diverge?
Yeah, I'll speak to that briefly, and then I want to hear Rabib's thoughts on this for sure. Tornado is doing a great job at advancing the privacy that's available to EVM-based chains and applications. I think that the way that I see Sherpa is more focused on bringing zero knowledge proof technology to Avalanche generally. So we're certainly starting with privacy. We're starting with this Tornado protocol offering on Avalanche, but every person on the team is very much a fan of zero knowledge proofs, and we all think that there's a lot of really cool stuff that we can do outside of just privacy, or even within privacy but outside the Tornado protocol. Things like building more native privacy tooling into, say, Pangolin, for example. That'd be great. That's, this is an example, but sort of being able to add these privacy tools to other DeFi apps and not just necessarily have these own little isolated privacy apps, but really build an ecosystem that allows Avalanche apps to be more natively private. So that, I guess the difference that I would see is that we're really more focused generally on bringing zero knowledge proofs to Avalanche, and the Tornado protocol is just sort of an initial stepping stone that we're using. So, but
I think this is
nice
a really
vision.
cool thing.
Yeah.
I think this is a really cool thing about building on Avalanche, because a lot of the projects that have come over to Avalanche so far have not been developed natively for Avalanche. A lot of them have been forks from Ethereum projects, and it's not necessarily the original creator that's been bringing them over. And because of that, there's this kind of like lack of ego or lack of, this is my baby kind of feeling around these protocols where, you can make something like Pangolin or like Sherpa Cash, and you can kind of grow beyond what Uniswap can be or what Tornado can be on its own, because you're not, it's not the thing that, I created. So like, I can't have integrations with other projects because this is just my thing and my thing has to be separate. We can kind of like, as more curators, more than like original creators, we have some freedom to integrate other projects and to see like what else we can do. How can we integrate these apps together without any of the kind of the drama and the feelings that come along with it? We can be a lot more dispassionate about it, which is something that I don't think is necessarily happening on Ethereum right now to the same regard. That's kind of special about Avalanche.
Yeah, do you want to give your thoughts, Rabib, on what you think that makes Sherpa Sherpa?
Yeah, it's I think at its core, originally it was about concerns for privacy on Avalanche, so and rectifying those concerns. So and I think going forward, what that might mean would be for the projects we've spoken about briefly about getting private swaps happening, for example, with Pangolin or other DEX perhaps. And also what we might end up with is like a subnet. Of course, I think one reason we ended up funding a validator in the first place was for the potential of a subnet in the future. So that's definitely something on my mind.
Cool.
Yeah.
So another question I wanted to ask comes from Twitter user Yuan. At the beginning, Sherpa will serve for AVAX, the token. Is there any plan for other cryptos, e.g. Sherpa or other ARC20 tokens? Is it possible to swap tokens on your platform with privacy, e.g. loading AVAX and withdrawing USDT a week later?
Yeah, Rabib, you wanna? I think you worked on this. You want to talk about it?
Yeah. So if I get the question correctly, it's just the main concern here is about other ERC20s that might be involved. So at the moment, we're currently discussing what the appropriate tokens might be. So of course, we're interested in stable coins. That's for certain. As to which stable coins we'd be going forward with, I think, well, personally, I'd like to get some kind of community input on that to understand which stable coins that the community wants to use, and that will, ultimately generate the most, the greatest anonymity effects in the protocol. So, but yeah, that's definitely, a possibility going forward. We have the smart contracts to enable ERC20 transfers using Sherpa.
What do you think about that, Connor? You seem like a good person who might even be a voice for the community in this sense. What would be your take on the stablecoin of choice to move forward on from the community?
Well, so for stable coins on Avalanche right now, we really have two. We have USDT and DAI. Those are really the only two with significant liquidity. However, the Avalanche bridge just a day or two ago added support for USDC. I don't want to talk too much about my preferred stablecoin. I guess personally, I prefer USDC, and I use that a lot myself. But as far as
is there
like,
a reason? Just out of curiosity.
I think they do a really great job with their auditing and their proofs, and I feel really, really good about them. Not to this, which is not me dunking on anybody else, but I feel like they do a very good job, and I feel very confident in the backing behind those, that they'll always be redeemable. Algorithmic stablecoins make me nervous personally. I can understand why people like them, but there's too many that have broken. DAI has been really great, but I'm not sure how much DAI has actually been tested. And, there's just so many, I'm not one of those people who ever would like ape into a stable coin like Iron or Fei, or what was the one a few months ago that broke very quickly that a lot of people lost money on.
I think they would.
Which one?
I think Fei had some failure close to the beginning. I'm not sure whether they ended up fixing what the issue was. I kind of just stopped following the news after that. But yeah, they had some serious issues with the price falling.
Yeah. So that's just an area of like such active research that just has not been subject to necessarily all of the scrutiny that the world will throw at it over centuries. And just the way that is, I'm just a little bit more risk averse. I'm not as distrustful of some of the institutions and some of the centralizing authorities in this case, that I feel okay taking that risk over the risk of the peg breaking.
Sure, as long as there's sufficient transparency and the backing is there and it's available to be audited, then that seems like a reasonable model, right?
Yeah.
Got it. Okay.
So one other thing I want to just cover before we wrap up is I just kind of want to talk about like the experience building on Avalanche and building a DAO and working with other members of the community. Because Sherpa, I know one of your other co-founders, Justin Trollope, is heavily involved in the Avalanche community, and you're talking about collaborating with Pangolin and all these other things. So I guess what has it been like building on Avalanche from a community perspective and like talking with these other leaders?
It's been really great. So there's all these different projects, but in a lot of ways, it doesn't necessarily feel like there's a lot of different projects. Like you mentioned, Justin, who
well, it's because Justin runs all of them.
Yeah, I was gonna say he's involved in at least half of them, and
he is the champion. Shout out to Justin. What's up, man?
He's gonna be on the show soon.
Good, yeah, that's gonna be a can't miss episode for sure. But we also have people from like Snowball Finance and a bunch of the other projects in the ecosystem that all have input in Sherpa. We've been doing a lot of stuff with Penguin Finance. So like the community has really been working pretty well as one big team, all pretty much having the same goals of trying to bring our own ideas to Avalanche and make them work. It's really been, it's fun because it's sort of like being on a whole bunch of different teams at once. You work on the Sherpa team, but then you're constantly like hearing from and giving input to all of the different apps that are going on in the ecosystem. And then we've been putting together all sorts of cross-community promotions and doing things together and sharing promotions with each other. So it's really been a great experience versus other projects that I've been in where each separate team sort of wants to be the champion and sort of every team wants to be dominant. And it's been very much the opposite in Avalanche, and I really like the DeFi and the dapp system that we have built up on top of it. I mean, the technical stuff is really great, but just the community and the personal side of everything has been really what's been, I think, the best part.
Yeah, absolutely. I think that sentiment. Sorry, that the Avalanche ecosystem is incredibly vibrant and super open. Like there's so much, cross-pollination between projects. A lot of, for example, the Abominable Sasquatch, who I believe started the Snowball project. He's an advisor on Sherpa Cash, So, that in addition to Justin, who's, project manager on Pangolin, Leo, who's community manager on Pangolin, is also our community manager. So, yeah, we have a lot of really interesting and fun collaborations between projects, and I'm really happy to be part of this ecosystem.
Yeah, I
Do you have any
always say,
advice?
sorry, go for it, Connor.
I was just gonna say, do you have any advice for people who are looking to get involved in any launching their own project or trying to join any of these projects, or just are interested in building on Avalanche?
Yeah, it's as easy as reaching out. And I think the best way to reach out is just send out a message to the admins in your favorite Discord server. We have a Discord server for Sherpa Cash, and if anybody's interested in contributing or getting involved in some other manner, whether it's by joining our community team, for example, we'd be really open to hearing about that sort of interest. And from what I've seen, this is the same across all sorts of different projects in the AVAX ecosystem. So I really encourage anybody that's interested in participating to go out into your favorite project's Discord server and, shout out to the admins there and just, see what kind of opportunities are available to collaborate.
Yeah, there's just so much to do, and there's sort of a philosophy of go and make your own value in places. So like watch on Twitter, see the projects that you're interested in, join the Telegrams and the Discord servers and see what the teams are doing and what the community's like. Lurk, see who's working on what, and then eventually you're going to see sort of where you're gonna be able to participate, whether it's casually helping people in Discord for a few minutes a week, or it's diving head in and starting to work 40 hours a week on some new project. There's no minimum or maximum amount of experience or previous involvement or expectations on future involvement or anything like that in this sort of growing crypto space. And it makes it very easy, in my opinion, for people to join. I think it can probably be a little bit intimidating at first because maybe people are used to going to a website where there's like an application to join a team, or a forum where you can go and you can say, hey, I'm this person, is there any work that you want me to do? But in these communities, it's very much more about just getting involved and first becoming a participant in the community yourself, and then just looking for places that you can help other people in the community. And I think sort of the natural result of being in crypto is that we've got these tokenized value systems that just sort of flow around. And so you can go to where you think you're valued. You can put in the work that you want and get rewarded for it, or not, and go somewhere else. It's a very organic and fluid process, much more so than previous things where you sort of you're on a team or you're not on a team, or you're committed to a project or you're not committed. And because of that, I think it's very easy for people to get started. You just have to go in and jump in and find some place to start.
Yeah, and to speak of one personal anecdote, I think one time I ended up finding some kind of misspelling on the Pangolin UI. So I just forked the code, then made a PR and told the lead developer on Pangolin, hey, I think, which right now is Brandon Mino, right? I told him, hey, on Discord, I put up a PR, maybe be interested in looking into it. And, he did, and he ended up merging it in. So, it's as easy as that to contribute. Just find somewhere to basically place yourself and add something of value, and people will recognize that.
Yeah, get in where you fit in. That's very inspiring. Yeah. I think it's been over an hour, and of course we want to be super respectful of your guys' time. So thank you so much for your time. Is there anybody you want to give a shout out to? Is there any last minute thoughts you want to add?
I'll just quickly, the whole rest of the Sherpa team, it's been Rabib and I on here talking today, and it's been great, but making Sherpa happen has been a community effort. just not just the other people on the official team, but everyone in the community. We had our trusted ceremony, which went way more successful than even we imagined, and that was all because of our awesome community, the support that we've been getting on Discord and Telegram. So yeah, I just want to say thank you to everybody both on the team and in the community for participating in this project and being interested and letting us help bring you this app that I think you guys are going to find valuable.
Can you give us a really quick, explain it to me like I'm 5 about that trusted ceremony and how significant it was?
Yeah, so just real briefly, the way that I like to describe it in simple terms is the ceremony is sort of like the community collectively generating a public key for which nobody actually knows what the private key is. And so this public key is sort of used to validate the Snark proofs that get generated. And as long as the entire ceremony did not collude together, meaning we had over 4,000 people, as long as any single one of those people did their job honestly, then there's no way that this sort of private key could ever be known. And that sort of underpins the security of the zero knowledge Snark. So the general idea is you want to have as many people participate as possible. As long as any single one of those people participates correctly, then you're good. If you participated yourself, then you know you did it correctly, and so you know that it's safe. If you didn't participate, then we had pretty much the entire community, more than any other zero knowledge Snark system has to date, that participated in it. So it's I guess that's the sort of long and short of what the ceremony is for, and my opinion on that.
Yeah, congrats on that huge milestone. In case you guys didn't catch it, as far as we know, that was the most successful with regards to users zero knowledge proof ceremony that's been out there in the public, again, like as far as we know. So huge milestone. Just congratulations. I hope you can take 10 steps back and see the big picture and appreciate like how significant that is. It's historic. Again, just really congratulations to you guys. I think that speaks to how much people are interested and how big the potential is for this to just have a radical impact. So congrats on that.
Yeah, I think more than, I just want to say, I think more than anything, it's a testament to the community and how involved people like to be. And so I just wanted to, again, shout out and say thank you to the community for making that happen. It's not like because we're so great, we had 4,000 people participate. It's because our community is so great that you guys participated. So thank you again.
Did you have any shout outs, Rabib?
Yeah, absolutely. Again, thank you to the community. Thank you to all of our team members, community team members, our IDO partners, Penguin Finance and Snowball. And yeah, it's been amazing working with everybody, and I'm just so grateful to be on Sherpa Cash.
So where can people find you both if they want to follow you on Twitter or wherever?
So for me, that would be _RABIB _. There you can find my tweets. I'm not a prolific Twitter user, but I definitely like to use it to follow everything that's going on.
Yeah, if anybody wants to find more about me, you can go to the website tcry.pt. It's sort of my landing page. I've got my amazing Twitter feed and my Telegram and all of that very great information there if anybody wants to talk to me about anything.
And of course, we'll add all this stuff in the description box below, so it'll be easy for everybody to follow up. I just want to, again, express gratitude to you both. I have a ton of respect for you both. Tyler, going way back, I've thought you're an absolute block star for years. It's nice to connect with you more. And Rabib, it's nice to meet you. I'll just extend the invitation to you guys. If you want to come back at any time, if you want to plug something you're working on or just want to chat with us, please give us the heads up. You guys have an open-ended invitation to come back anytime you guys want. Connor, anything you want to say to wrap it up?
Yeah, absolutely. So for those of you who are watching, I'd like to let you know that we now have an audio version of the podcast. So we are currently live on Spotify, Google Podcasts, RSS, Anchor, and a couple other things. We don't have iTunes yet, but that's coming. I'll probably be up next week. So Subnet Show available on podcast services around the globe. We'll put a link in the YouTube description. And we also have a Twitter account now, Subnet Show on Twitter. So all the places you can find us, all the places you can listen to us, going to be easier than ever. Gabriel and I have been talking about a lot of improvements we can make to the show, trying to make this the best show possible. And now we're going to be bringing on more guests from outside Ava Labs, starting with half of the Sherpa team that's not from Ava Labs. But yeah, we've got some great guests lined up in the Avalanche ecosystem, and it's an exciting time to be a subnet listener. But in the meantime, while you wait for the next episode, you can find me on Twitter at DAS_Connor, DAS_CONNOR.
And then myself, you can find me at CG Cardona, CGCARDONA. And yeah, I just want to say thanks for listening. We also have a subreddit. That's another thing we created. There's a subnet show subreddit. We really are trying to build a community. We see a lot of potential in the subnet show. Obviously, you know, a podcast done well can be incredibly powerful, and it can, you know, really bring together a community and really get some ideas out there. And so Connor and myself just have been doing a lot of brainstorming. We have a lot of ideas, and we really do want to take the subnet show to the next level. And so stay tuned in. It's going to get better and better. We have tons of guests on the roadmap, and we have lots of ideas for ways to make the content very compelling, and doing deep dives on code bases and all kinds of other exciting stuff. So thank you guys so much. We will be posting this up as soon as it is ready to be done. We're going to spend a little bit more time and have a regular posting schedule, and do a little bit of post-recording editing, and, you know, just kind of take the quality up to the next level as well. So I think that's it. I think we're going to wrap it. Thank you, gentlemen, so much. Thank you, everybody, for tuning in. This is Gabriel Cardona, and this has been another edition of the Subnet Show. Thank you so much.